Hello everybody, we're going to look at solving problems with kinetic energy or gravitational potential energy. So let's go ahead and take a look. Just a reminder, these are our 7 steps that we're going to be using as we go through this process. Alright, let's get started. You serve a volleyball with a mass of 2.1 kilograms. The ball leaves your hand with a speed of 30 meters per second. The ball has blank energy. Calculate it. Okay, so for this activity, first we have to decide if it has kinetic energy or potential energy. If it has potential energy, that means the energy is stored but not being used. Remember, we can't see potential energy, but we can see when potential energy becomes something else. So the volleyball leaves our hand. That means it has a velocity. Because it has a velocity, it means it's moving. We have the energy of motion. So it has kinetic energy. Now our other clue is we can use our equations to help us. Kinetic energy has mass and velocity as part of the equation. So if it mentions speed or velocity, well, then we know we'd have kinetic energy. If our equation mentions how high something is or mentions something to do with gravity, then we know we're dealing with a potential energy. Alright, so step number 1, annotate our problem. Our problem says mass of 2.1 kilograms. So that's going to be our M value. And a speed and meters per second tells me that that's a velocity. And again, we're trying to find the kinetic energy. So we're going to write our formula in the top of the workspace. I'm going to write kinetic energy is equal to 0.5, so half of the mass times the velocity squared. That's step 2. Step 3, under the formula, we're going to substitute each value that the problem gives us. It did not give us a kinetic energy, so KE it is. It does not need to give us 0.5, that's a constant, so that stays constant. Our mass is 2.1 and our velocity is 30 meters per second squared. Let's look at step 4, identify constants and variables. So I've got a variable over here, my kinetic energy, and I've got a bunch of constants here. Cool. We're going to do any calculation with the constants that we can. So if we have any numbers that are just pure numbers that we can add, subtract, multiply, divide, we're going to do that. I have a bunch of constants right here, so I'm going to go ahead and multiply and divide them or do whatever it asks me to do through the magic of the video. Alright, through the magic of the video, I put the calculation into the calculator and it gives me a value of 945. So my kinetic energy is equal to 945. I'm going to double check step 6. I did all my calculations. I should end up with a variable on one side and a number on the other. In fact, indeed, I did that. Step 6, I'm going to divide both sides by the number that's in front of the variable. Oh, well, I don't have that. So I don't need to do step 6. Step 7, don't forget my units. I have energy, and my units for energy is always going to be joules. All right, let's look at problem number 16. A baby carriage is sitting on top of a hill that is 21 meters high. The carriage has the baby has a mass of 1.5 kilograms. The carriage has blank energy. Calculated. I have a clue. It mentions height here. It mentions a mass. That's a clue that it's potential energy. My other clue is it's sitting, meaning it's not moving, and it's at the top of the hill, which means it has been lifted up away from the ground. It has now energy stored in it because of its position. This has potential energy, specifically gravitational potential energy. So let's calculate that. Okay, step 1, annotate our problem. 21 meters is our height. 1.5 kilograms is our mass. Let's go ahead and put it in. I'm going to do over here with a little more space. Gravitational potential energy is equal to mass times gravity times height. Well, it does not give me a gravitational potential energy. It does give me a mass. Now for G is the acceleration of an object due to the gravity of Earth. Because we're on planet Earth, it's always the same. And we're going to use 9.8. G is always going to be 9.8. And our height, which is 21. Back to our steps. We have substituted everything in, constants and variables, variable, constants. And we're going to do some calculations. Anything where constants can be added, subtracted, multiplied, divide, squared, whatever. Over here, in this case, I've got 1.5 times this times that. Those are numbers. I can do math to them. So I'm going to do the math to them through the power of video. Through the power of video, here it is plugged into the calculator. And my answer is 308.7, 308 So gravitational potential energy is 308.7. Now, there's nothing to divide. There's nothing in front of my variable. Don't forget my units. My units are joules. And there we go. We have a kinetic energy problem and a potential energy problem.